Hello, welcome to the Bottlenecks Institute podcast, where we discuss the critical bottlenecks that hold progress back. We are hosting a special sub-series on AI safety and security focused on the challenges we must solve to accelerate safe progress in AI. I'm your co-host, Pranyan Barakatin.
And I am your co-host, Ian Darrington. Today, our guest is Evan Myaznono, who holds a PhD in applied physics from Caltech. Evan previously led research at Protocol Labs, where he launched their research grants program. Most recently, he founded Atlas Computing, spinning out two organizations, and he also serves as a research fellow at Convergent Research. His work lies at the intersection of AI security, formal verification, and flexible hardware. Evan, welcome to the podcast.
Thank you so much for having me.
Great. So our audience can get to know you a little bit in just a few sentences. How would you describe what you're working on right now?
So at Atlas Computing, I would say we're trying to close the gap between research efforts and groups like think tanks, where to them, they understand the problems deeply and their end product is a report explaining the problems very deeply and possible solutions. And on the other side, startups, incubators, nonprofit organizations, focused research organizations that are teams who have the context on problems and also the resources and network and skills to go and pursue solutions. I think oftentimes to be the person to create one of these organizations, you need two disparate sets of requirements. Need to be two disparate sets of requirements. One of those is having the skills to actually solve the problem, which can be meaningfully separate from having the context and connections and support to actually go and understand and pursue what solution is best and recognize that solution for what it is. So we aim to close this gap, deliver something like a gift basket to potential team leads of here's everything you need to deliver real impact and close a bottleneck. And the other half of my time, I am working at Convergent Research, where anything that should take the shape of a focused research organization, I can then pick up on that side and run using the Convergent Research connections and partner with them and the fantastic team there. For those who don't know, a focused research organization are these scoped R&D efforts that drive towards specific outcomes where you don't have the problem of nonprofits maximizing for endurance or focusing on fundraising. They're focused on, at the outset, these are fully resourced 2 to 5 year, $10 to $50 million nonprofit research efforts creating a data set or a protocol or some open source software that is a new public good that can be a product that seeds an ecosystem that launches a scalable revolution.
That's very nice, particularly be by your effort in AI security. And kind of wanted to get to the heart of that a little bit jokingly, and that is asking the question, will AI terminate humanity? And what's your take on that?
I think that the non-consensus or the interesting reply is that there are some ways in which it is terminating our humanity as it stands, and technology has always changed what it means to be human. I think that there is an underemphasized risk in most minds about the extinction risks from AI. I think this is something a lot of, for instance, AI CEOs have given lip service to, and some are backing with action to improve the safety. I think we're seeing meaningful gaps in reliability, and there is strong evidence that these systems want things in the same way that a heat-seeking missile wants to hit its target. And we do not know how to set what these things want. We don't know how to read what they want. We don't know how to deterministically modify them. And if you have something that you're trying to make a problem solver better than any human, there becomes a point, if you can't set the goal and you're trying to be a human between the AI system and the reward, at some point you become the easier problem to solve as a human than the thing that you are trying to get it to do. And so I am very worried that people assume that an AI system defying what you intended to do is science fiction. And I think that there is evidence that it is happening now. And the fact that people I think many of the people thinking about risk in the future look at the technology today and imagine extrapolating adoption, and they don't extrapolate capabilities. The most important graph, I think, for AI risk AI capability, any kind of AI forecasting at the moment, is the graph from Meter, where they look at the time scale on which AI systems can autonomously work. And the current systems have for the last few years followed an exponential, and with reasoning models, there is a faster exponential that these systems are following. And I think that the doubling period is roughly 7 months in terms of the amount of time that these systems can act autonomously. And if you extrapolate this, assuming no new breakthroughs in architecture that give us a new exponential, this starts looking like automating and replacing meaningful amounts of knowledge work in a few. Oh, I should check. I think I can give you a actual
Detailed.
number.
So it sounds like you're kind of worried about automation and doing things both directly as well as maybe a higher level extinction risk. So extinguishing the way that people work presently, but also as higher level sort of, oh, we got to worry about Terminator really getting us.
Yeah, I think that the I think worrying about a bad person with capable AI is probably a little bit underrated by a lot of technologists. There's a general, I think there's been some interesting and important trends between like early 2000s to 2010s to now around how responsible an inventor should be for the impact of their inventions. And I think that some people will argue that if you solve a problem, then what people do with that technology doesn't matter. And I think that there are some really interesting instances where, for instance, Alfred Nobel or Winchester deeply regretted what they did after the fact, and other instances where, like, the person who invented CFCs and leaded gasoline, same person, possibly one of the most negative impactful inventors in like human history.
That is very interesting to look the negative impactful invention from like historical example and see like what was the outcome of this would be like similar to like
Yeah,
nuclear like bomb right now is like yes it's very useful at the same time it's also that invention of understanding nuclear fusion was exceptionally useful but then also the downside was nuclear bomb that we caused like huge geopolitical issues that we are like facing like right now
yeah.
and
As a brief aside, I just pull up the plot. The faster reasoning timeline sees roughly a work month worth of autonomy by roughly July of 2027, according to the graph I can link to you separately. I also wanted to note, related to on the topic of AI systems being a new technological development, possibly on the scale of impact as splitting the atom, the metaphor that I actually reach for in terms of how impactful this technology will be is much closer to either language or tool use in humans. I think it's very interesting when people who are the most pro and the most concerned about a particular technological development tend to be the people who are most optimistic about what is possible. And the concern becomes about other contingencies. I think that, for instance, language and tool use were not particularly good for other hominids. And I love the example that AI won't necessarily do for humans what the Industrial Revolution did to humans. It may do to humans what the Industrial Revolution did to the horse.
great analogy. Before we get into the technical details, you prefer the term AI security over AI safety, and I'm very curious of what that distinction matter to you.
I think it's a really interesting and important distinction. There are all of these labels are only important to the extent that they identify people and ideas. And I think that the AI safety community now has a lot of baggage with it. And if you look to maybe 2 years ago, there were really two sets of people who were thinking current trends in generative AI, transformer based models, could be very dangerous to people generally. And one set of those people were often effective altruists, often in the circles of Miri or Less Wrong or groups like that. And that is its own heterogeneous large umbrella. But the other group, it was and has continued to be members of the federal government, particularly people who worry about defense and national security. And it's been very interesting trying to bridge those. When I started Atlas Computing, my CTO, I actually recruited from a defense contractor who was working on primarily projects for DARPA. And I think that even that starting point, there are real security concerns, but this technology might hold meaningful promise for capabilities, the likes of which we have never seen before. Was a fascinating start to Atlas, and there aren't many other groups I've seen out there who try to straddle both perspectives as well. I'm at least one of the few people who shows up to the AI and formal verification and also the defense-centric formal verification conferences.
What do you do differently if one's safety versus security? What are the actionable sort of ways that you go about things from maybe a different strategy or perspective to enable AI security versus maybe the way that AI safety is being done presently?
I really like that you bridge the gap between the government versus the AI safety community, like a rationalist that consider their own cult from the outsider view. So being able to bridging those communication and some of the real concern, but also like how can you communicate those to actual places that are in charge of deploying security at scale.
Yeah, I think that finding out what arguments convince different people has been fascinating. One of the things that I imagine many viewers may not be familiar with, The Bitter Lesson. It's a short essay by Rich Sutton about the two paths that humans have taken, researchers have taken towards improving AI capabilities. And one of them is try to identify what your knowledge and understanding is and encode it into the AI system. And the other is try to scale up and grow an increasingly complex system and have a scaffold that can internalize abstracted patterns and generalize from that. And I think that the recent trends in AI, the recent capabilities have all been driven by this bitter lesson that if you do the latter path, if you just build a structure and grow the capabilities within it, it seems to work better. And I think some of the mindset and the problems that one has to solve when working in national security or high assurance systems, these are lessons that directly compete against assumptions or realizations you need to have to accept the bitter lesson. And so I do not argue for AI systems that will be conscious if they end, like as they're ending humanity. I think that really there is some amount of like paperclip optimizer, heat-seeking missile, drone swarm type thing where if something goes wrong, whether or not it realizes what it's doing is no longer relevant. We don't need something that is smarter than every human if it is better at solving certain problems that are the only problems that are in its way. And it's possible that systems don't need to teach themselves how to learn, even. They could just get good at the benchmarks that we put in front of them, and that may be sufficient for catastrophic risks. I don't know if I have a good answer for the difference between safety and security in terms of like actionably what I do as a security person versus what I would
That's
do
kind of
as
a
a safety
branding
person.
thing more than anything else, would you say?
I think it's branding. I think I forget who it was. Someone high up in the current administration said, like, beware of all the safety people. They are actually just these effective altruist rationalist paws, like Luddites in disguise. And like there are some people who are rationalists who do consider this a branding switch and not changing what they're doing. I also think that there isn't a good label for people who are actually just worried about improving national security. Turns out if you kill off all the humans, you've killed off all the Americans. There are a lot of people in the DoD who like get really annoyed if they think someone's going to try and kill off all the Americans.
Yeah, no doubt. Maybe kind of continuing on what you're saying about drone swarms or something that is paperclip optimizing. Is it possible that the problem is not producing a super intelligent AI, it is producing that is one that is not super intelligent enough?
I don't know if I believe that risks go up every time intelligence goes up, but I do know that if you have something that is smarter than every human, you cannot control it, kind of by definition. As an intuition pump, you can imagine how long a group of 4-year-olds could keep you as an adult prisoner. I think you'd be able to trick them relatively easily, especially if you were running on every data center in the world, had access to the internet, could copy yourself, and could run roughly 10,000 times, or is it 10,000? Something like 10,000 times faster in time. I think that there might be some local minima where you make the system more capable and it becomes safer. But I think that the problem of either alignment or control, which I will put as two separate approaches under the safety or security or like risk mitigation umbrella, are somewhat orthogonal to capabilities in many extents. The control side is really, we don't trust the AI system. We will continue to not trust the AI system. Can we have mechanisms to detect if this system is trying to betray us or work to its own ends in defiance of our ends? And there are alignment approaches where you're going to try to modify the AI system so that it does, in fact, encode your preferences and does do what you would do if you were, in fact, a super intelligent digital system. I think pursuing both is worthwhile. I am somewhat skeptical from a pure governance and like social or public choice theoretic perspective about, or even just like from a democracy perspective, I worry a little bit about the notion of alignment solving this. I think that the world in which we have one or a very small number of companies deciding what societal norms and values are, even if it then gets tailored to you personally for your AI system, I think that there are many questions around things like explore versus exploit or prevention versus cure, where unless your AI system has discovered objective morality, it's not going to have a right answer. And your preferences are as valid as my preferences, and democracy makes it feel like we should have a way of expressing and having those preferences incorporated. So I tend to like control more, but I think that I would applaud huge breakthroughs in either. Both have a governance problem. The nice thing about control is that we have tools for people to come together to express what their preferences are and to aggregate those. And like I arguably like all legal mechanisms are ways of expressing and concretizing control in a way that presumably people kind of understand. And on the alignment side, these preferences are aggregated in a way where the weighting of different preferences against each other is very opaque. And it is an active research effort to determine why an AI system said this thing, given all the various inputs. If you are aggregating policies that you are then controlling AI against, you have this really nice property that that policy should be something that is human interpretable.
In the related note, I'm also very interested to hear your take here. In your essay, Govern with Rules, Not Values, use the analogy of hiring contractor for kitchen renovation. You wouldn't explain your life philosophy and hope they figure out the right cabinets. You instead give them a specification, measurement, materials, deadlines, and acceptance criteria. That way, the process is verifiable and produce exactly what you asked for. Can you unpack this idea and also tell us more about formal specification and verification in AI?
I would love to. I think that a good way of thinking about this is that AI systems, given an input, will produce an output, take an action, something like this. The more you specify up front about what it is you want, the more likely it is for the output to be that thing. If you can specify very concrete objective properties, for instance, this tile in this orientation across that entire backsplash, or this software function should give an output as a function of this input that is this mathematical function. If you give something that objective, you can have some quantifiable evidence at the end that the system did in fact give you what you wanted. Another great example is here is a bridge. It needs to be able to hold 50 tons. The way that we do this out in the world with civil engineering is we have some fairly agreed upon set of world models around material strength and how we measure it. the statics and dynamics of bridge construction. And if you say that and you add in a safety factor, the contractor can generate for you the evidence that you would need to trust that that specification is in fact met. The example of implementing a particular function, a mathematical function in software, this is something that falls squarely in the field of formal verification. And the notion that we want some very high assurance systems to not fail, we actually rely on formal verification for things that are either very small and expensive if they break, like smart contracts for cryptocurrencies, for things that are highly valuable and reusable and are very well specified, like the SEL4 formally verified microkernel. We also use this for things like the transistor layouts for some fraction of microprocessors to be confident that the transistor layout actually implements the function we want. So this is a technology that's fairly mature. There are a few problems. One is that it's pretty hard to formally specify all the properties you want and be able to say, these are the objective criteria. If we do this with a kitchen renovation, I think most people wouldn't care about most of the details. And there's also kind of a discovery process of knowing which details you actually care about. I love to say that a bad contractor will listen to what you want and say, okay, and then go and do exactly what you asked for and curse you with what you wished. It's amazing to me that feels like every culture kind of has some mythology about someone getting exactly what they asked for and hating it. A good contractor will hear what you want and say, that isn't what you want. If I give you that, it will break in this way, or it will do this thing, or it'll cost this much. What are you trying to accomplish? And they'll understand this, and they'll bring their model of the world that is relevant and help you identify what it is you want. I think this is a thing that AI systems can do. And with Convergent Research, I'm building a focused research organization around building tools to make it very easy to elicit specifications from someone who does not have experience in formal logic. That is one prerequisite. Also, once you have that spec, being able to, for a software, generate software and generate a mathematical proof that the software satisfies the spec. Both of those are very hard tasks. I am a believer in AI capabilities and their ability, in the fact that they will increase. And so I think future AI models will do that fairly effectively. I think the frontier labs will put in a non-trivial amount of work to make that happen. But having a good set of specifications is a sufficient benchmark that I think we should expect a tectonic shift in what is possible in the field of formal verification by leveraging AI systems as a load-bearing component. I also think that there are a lot of interesting extrapolations one can make from, if we can formally specify and verify software properties, what else is a spec? Where else do we do this? And there's a great talk by someone at OpenAI that I have not spoken to, but I watched this talk. Okay. There's an amazing talk by Sean Grove at OpenAI, with whom I have not spoken, but I watched this talk and I'll link it to you. And the whole time I was just cheering yes, 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 until it got to the end. I was like, but make the specs formal, make them objective, and then the AI system can prove to you that it did what you wanted. I claim that there are going to be many instances where a human iterating on a formal spec with an AI system before the AI goes off and generates the thing it'll trivially be more secure and more stable, but I think it will also actually be faster and cheaper because people don't know what they want until they either see this and are told this isn't what you want, or they're asked wait, are you sure you want that? Because this is an implication of that. And they can say, oh, you're right. Yeah, no, I don't want that. What are my other options? Yeah, that one. And so I think that there's this kind of iteration where it definitely provides a huge improvement to safety. If you could formally verify parts of critical infrastructure, I think you could have a meaningful reduction in the number of blackouts or the number of attacks like Salt Typhoon, Volt Typhoon, Solar Winds-esque things, Sandworm-esque things. These are all very famous hacker groups or hacks that I think people who care about security or people who care about being able to plug their appliances into the wall and have them run should probably be aware of these. It's very unsettling how insecure many aspects of critical infrastructure are despite best efforts because of just how under-resourced the groups are and how much they have to err on the side of being conservative because they don't know exactly what this new alternative system does, and therefore they cannot trust it. And I think that formal verification could meaningfully improve that for grid security in the same way that it could improve how much you trust that this AI system bought you the item that you wanted and didn't spend over the amount you specified because you generated something like a formal spec for it.
That's really excellent and kind of really dovetails very nicely with like the purpose of this meeting and talking with Bottlenecks Institute co-founders. And that is there's problems, there's challenges. We're really curious as to what you see the main bottlenecks that prevents formal verification from being used widespread in all AI systems.
I think that there are a few different ways you could think about implementing formal verification with AI systems. One is any code that it generates. It would be great if it were just formally verified code where the person interacts in natural language and they get back, here are some criteria that it seems like you want. And that becomes a succinct, human readable description. I guess there is this open question of why would I want something that is an expression of what I want in formal logic when I'm a software engineer and I wrote the code and I understand the code. And the answer should be that many of the things that you actually want software to do are not as procedural. What you care about are outputs as a function of input, functional requirements, type signatures. You might care about properties like memory safety. Memory safety is a very succinct, well, maybe not very. Memory safety is a succinct thing you can express about a code base. It is a very intensive thing to demonstrate about a code base. And so I think that it's probably pretty likely that we will get to a future where people mostly reason about natural language and formal specifications of software they are generating with AI because that is a more timeless or more robust way of thinking about what software does. And I'm very excited for this paradigm because I think it also massively democratizes the effort of software engineering if you can ask questions about a spec and understand them much more easily than you can ask questions about an AI-generated vibe-coded code base. There's also the question of deploying formal verification to have as an AI control tool. I think that formal verification, or there is a subset of people interested in AI control where some are interested about increasing confidence with things that are more reasonable to deploy, things that are cheaper, things that are lower overhead. There's also a subset that is much more ambitious, that are envisioning human level or more capable AI systems as load-bearing components in the systems they're designing. My favorite two examples of this are the guaranteed safe AI architecture, which has a bunch of very recognizable names like Yoshua Bengio and Stuart Russell as co-authors, Max Tegmark. And I am fairly close to this work because I used to be the manager providing top cover and support to the first author on this paper when he was working on my team at Protocol Labs. And so I'm very interested in this architecture. I think it is insanely ambitious. I am overjoyed that Aria is supporting it by hosting Davidad to run a full-scale program on this effort that seems to be making non-trivial progress. That program is kind of the other thing I would point to in this space, which is trying to implement the guaranteed safe AI architecture. This has kind of three components: a separable, auditable world model. So think physics simulator that is how the AI system understands the world. And it uses this, or there are tools for people to look at the system and say, these are aspects I want, formal specifications of what safety means to me for this system. And then the AI system, when it generates you anything, will prove to you using the world model that the specification is satisfied. And so you could imagine as like a scoped version, something like we've specified all of the constraints on the electrical grid, what the various load capacities are, how we expect customers to be able to or want to change what demands they're placing on the system, what generation capacities there are or might change. And the AI system says, all right, here is how you balance it. Maybe here are additional transmission lines that you should build, and a proof that if you do this, the system will remain within spec. In this case, the world model is checkable. It is deterministic enough that you don't have to trust the AI system to just tell you, like, yes, I made the system safe. And you're like, what about this case? Oh, you're right. That wasn't safe. Here's a version, which is kind of how I think the current direction would look.
Question, does that mean the
Yeah.
world model also needs to be predictively accurate to a high degree?
Yes. And I would say that when we talk about the benefits of formal verification, and if someone's listening to this, I'm gesticulating meaningfully, but there are kind of four components to formal verification. There's three gaps because of four pieces. There's what you think you want, which may or may not be complete, may or may not be an accurate description of what would make you happy counterfactually if I threw you into that future. There's what you say you want, which has to be a lossy compression of this. There's what you think you got, and there's what you actually got. The gap between these two is the what you think you got and what you actually got gap is the gap of the world model. To the extent that the AI could discover new physics or find bugs in your simulation, there are risks that could fit through this gap. But if humans and machines are all using the same model, and that is our ground truth for the understanding of physics and all other sciences, then I think you can reasonably expect that this will be robust. Formal verification, the proof that the thing you got, grounded in the model, matches what you specified. This is what the formal verification proof gives you. It closes this gap and makes sure that you can't fit risks through there. And the gap between what you think you want and what you got, this is what the fro that I'm trying to help convergent research form, or form over at convergent research, close this gap so that you have high confidence that what you think you want is actually what you specified. But all of these have risks, and formal verification really just closes this one, which shouldn't be assumed to be a guarantee of, or a complete guarantee. It should be a guarantee in the same way that, like, normal engineering has this as well. Your elevator may not actually meet its load limit if you didn't understand what load limit meant. Maybe the load limit is people and they're jumping and that breaks. Maybe the certification process was flawed and they didn't actually build what they thought they built, what they spec'd out. And maybe there's a change to the world model. Maybe no one was thinking about people spontaneously, or unsurprisingly, it's hard to think of things that people haven't thought of in their world model. Me to make it obvious, like maybe no one considered like wind shear straining the elevator cables, for instance, like wind shear on the building, straining the elevator cables. If that was not incorporated in the model, then any guarantees from the rest of this are broken. But the hope with guaranteed safe AI is an AI native approach to applying security measures that we have for other fields of engineering to the actions of AI systems themselves.
So what would you say the important ingredients are, and maybe also bottlenecks are in building these world models that seem to be a very important first step?
I think that there's enough skepticism around the generalizability and universality of these world models that what the Safeguarded AI program is doing is very compelling. I also think that one of the more important bottlenecks might be the appetite for specifying things and demonstrations that formal specifications of various things out in the world provides real value. And I think that if I were going to point to something for people who are listening to or watching this, it would be something close to this blog post that I wrote about formalizing non-software policies, with the idea being that there are lots of things out there that are specifications, and I actually have like a short list of companies or products that do some meaningful formalization somewhere within a very scoped world model, and they show huge efficiency gains. One of them is this startup Symbium that gives you one-click approvals, building code approvals for your ADUs or your rooftop solar installations in certain districts in California. Because what they did, and that doesn't seem like formal specs, until you look at realize that someone involved with this founding of the company was a logic professor at Stanford. I'm willing to assume that they formalized meaningful parts of the building code and made it programmatic, and therefore you can just check it like software, see if this is valid or not. There's a project called Project Catala that was a research effort to formalize parts of, I think, the French tax code. if you have formalized the tax code, then you can have high confidence that the loopholes that exist are loopholes that are intended, for instance. But you could imagine generalizing this to other types of regulation. There's a startup, Amandra, that has formalized parts of financial regulatory compliance requirements on financial markets, and they can prove that your market is compliant. We could imagine this making all regulatory requirements like push button approval. And my favorite part about this is that you can actually do this incrementally. You don't have to say, like, here are all the compliance requirements. Give us this thing and make sure that you do this. And first off, people with government contracts producing things in my conversations have told me that 40% of the effort is on doing the thing and 60% is on demonstrating compliance. And if you made these compliance things objective, I think that one, AI could help make those things objective. Ideally, the thing that this pro makes could make it reasonably easy to help formalize your compliance requirements. You could imagine that there's probably a power law distribution on how annoying these requirements are. You could imagine starting with the worst one and formalizing that and saying, if you provide links to robust or trustworthy oracles and computational evidence that you've satisfied this requirement, you get to jump to the front of the line. That reduces the time that the compliance checkers have to go through this natural language paperwork and understand, does this actually meet compliance, which is, as I understand, a large delay in the system. But also, it reduces the burden on the companies that are producing goods, because in probably a small number of years, AI systems will be able to generate that computational evidence. The main bottleneck then becomes, are there people who are willing to adopt this on the regulation side and the performer side? I think the regulators might be able to drive performance. This should meaningfully reduce the number of regulators that you need in order to run systems. And it increases the scale because you're not making these evaluations after the action has been taken and doing it for every performer. You're doing it a priori, and you can apply it universally to all of them. And so this is how I feel like there are huge win-wins to be done in anything that looks like a policy. This could be government compliance requirements. This could be HR. This could be data privacy. I think that the potential gains for privacy, user privacy, is huge, because now if users could specify this and it becomes very cheap to prove it, then it becomes very expensive in terms of gaining users to not make it the more privacy preserving thing that if people can quickly see, evaluate, and then switch to the thing that is better.
It seems to me that almost for all the field, we need formal verification and a specification benchmark for AI models to go after.
I tend to think so. I think that there is a meaningfully better world where we have human understandable specifications and AI systems generating proof that they are meeting these specifications. I think if we don't have this, we are putting way too much trust on systems that have already been demonstrating themselves to be fairly unreliable.
And also based on the conversation that you mentioned, to me it seems that policymakers, they become formal specification designers in a way. Like the policy become a formal specification by its own.
I think that would be a very good outcome. I think there's also, I guess this loops back a little bit to what I was saying about control being more democratic. But I think that one of my more controversial takes is that we might see a schism between the true technocrats and those who believe in, like, more in, I don't know if it's quite democracy. It feels like a generalization of democracy, of like humans having insights and opinions and perspectives that should be weighted in some way. I feel like to some extent capitalism is weighting opinions by amount of capital, where democracy is it's just by personhood, or like maybe where you live in some strange way. But I think that this split may show up because if your AI system is kind of invisibly making a lot of decisions behind the scenes, then and you're okay with that. You're a technocrat trusting the technology. If you are a believer in democracy, then you think that there are things that people have opinions on that should be incorporated. And unless you understand and can trace how your opinion was incorporated, we're in the technocracy version. This works for politicians and policies being formal specifications. because you get AI assurances against it. But as like a brief argument for why I think alignment alignment with societal values is not enough. If you trust an AI system to generate a piece of software based on a vague prompt and its alignment with societal values, then you're kind of implying or assuming that any time an engineering manager and a product manager disagreed, that one of them was misaligned with societal values. Or you're saying you are a better manager than every manager who has ever existed who has had people on their team disagree. So
Really curious about that in terms of the flexibility versus, evolvability and adaptability of these specifications. Because if you've ever built software or even cooked a meal, you kind of continually adapt and change it and, add more salt or change an ingredient here or there. And it kind of changes over the end of it. Can you maybe address that in terms of how it would work with formal verification in practice?
there's a really good quote by Sean in that talk about informal specs where he says, if we are writing natural language specs and generating code from it, and we only save the code, this is quite an analog to if we were writing in a high level language, but only versioning our binary and we throw out the source code after we compile it. There is a sense in which if the first class artifact becomes the specification, then obviously you version that and you can modify that and iterate on that over time. And everything downstream gets updated and you get the proof back coming upstream. I think that there are questions about how you do go about updating these processes. I would love to see something that, by current standards, seems somewhat extreme around. I would be very interested in seeing AI systems that have to show some safety properties of every output all the time just to run on hardware. Maybe there's like, if it's over a certain size or something, like some other reasonableness requirements, so this isn't a huge overhead. But I think that there's a point where the downside risk weighed against a meaningful but shrinking cost makes this kind of a no-brainer. Maybe it's a no-brainer only in the result of, or only in the aftermath of a recoverable large-scale catastrophe that changes people's perspective on this. But I think that if we don't see some cataclysmic change to how we are building AI systems or funding their research or things like that, I think that we will see a catastrophe. And the question is, will we take action as a result of these in time to prevent something that is unrecoverable?
I guess my next question is also based on one of the recent blog posts that you wrote about the sleeper agent. And I wanted you to unpack that idea and tell us like what the sleeper agent is. And also we can go more in detail. You mentioned about red teaming and blue teaming approaches to defend against these kind of risks. So I just wanted to
Yeah,
unpack that for our audience because I think that's a very important topic also to cover here.
I appreciate it. I was very excited to write this up because I think it ended up in a place where it's something that people who are very worried about AI risks from superintelligence on the like we should pause AI side, all the way to people who are hardcore China hawks would agree that we should do this thing. And I tried to design it as such as like, if there is appetite for a large scale funding effort, billions per year, what would that look like? What do I think it should be? Not that my only qualification was that I hadn't found anyone else who'd written anything public as like a plan. And I was delighted that IFP offered me a chance to write it in their launch sequence. And so I largely through like conversational ideation with many people landed in a place where I thought sleeper agents was the right demonstration. It probably more the more succinct way of saying the thing that I think makes this so appealing is that there was this demonstration. I think at this point a few years ago there was there was a demonstration early last year of sleeper agents. And these are basically AI systems where you've modified them slightly, and under some trigger condition, they do something that is not what you would want them to do. And so an example was in the paper, once the date it is told is today's date is after a certain point, it puts backdoors in the code. But I think this felt like something that was very intuitive. We have book/film, The Manchurian Candidate, that talks through an example of how doing this with humans in like fictionally. We have like notions of sleeper agents from brainwashing type explorations. It's very easy to understand AI's not doing what you want because of an outside actor. So I guess there are two things that led me to saying if we had billions of dollars as a country that we're allocating to improve outcomes with AI, we should not nationalize the labs. I don't think a government run version of DeepMind does better than DeepMind. I don't think that we should just do monitoring because I don't think that's enough. I don't think that we catch things in time necessarily. And I don't think it has enough teeth, really. I think that providing support in a meaningful way becomes really interesting. And the support that I would want is support across the supply chain and that addresses what I think is a sufficient concern that if you address that, you would address nearly everything else or plausibly improve everything else. And I thought sleeper agents fit this because you could imagine at either adding of data through some kind of data poisoning or modification of the training practice or post-training or in deployment, someone could make a modification that would lead to an AI agent misbehaving as the adversary wants, but not as you want. I also think it has this nice property where if there is some kind of latent misalignment from the data where the AI system, as I said, we don't know what these systems want. They seem to be maximizing something, but we can't read and write what that thing is exactly, or even explain or reason about or specify what properties of an outcome it would want to maximize. Because we can't do that, tools that would help detect a sleeper agent would detect all of these other types of emergent misalignment risks. And so I wrote up this proposal where it was specifically framed as we should have a red team to identify what all the weaknesses are in the supply chain, in all the algorithms, and also try to trigger sleeper agents so that a blue team can build tools that will help secure AI systems, detect and prevent the types of risks for these systems that we're going to be increasingly embedding into civilian and military infrastructure. There's an extent to which I don't think that anyone, when designing the internet, thought this is going to be an adversarial environment where you cannot trust the other person. I mean, when ARPANET was first being set up, like everyone knew everyone else who was involved in the project, and imagining that there are security concerns that you don't even imagine then. If everything we do becomes mediated by AI agents, you really want to know that your AI agent isn't going to, maybe at the mention of like one particular city in Poland, become very, very dovish and an isolationist and stop helping you identify targets for the country that just invaded that one particular city.
Along these lines of red teaming and blue teaming, kind of at a different level, and maybe there are the concept of sleeper agents at the level of an autonomous AI organization. Are there any sort of principles or guides that we could start to put into place at a very functional level, what you would start out with? You got to do this, this, and this, and then it'll start to be something that we can deem as safe and secure and reliable. And is that just formal verification, or are there other things?
I think that there's very much a defense in depth approach that should be taken to try to provide assurances for each and every like meaningfully integrated AI system. I don't think that I'm being particularly innovative here, but I think that you'll want to see things like strong security guarantees at the hardware level. You'll want to see supply chain robustness that's probably a combination of cryptographic and normal traditional people with guns or cameras type thing. You'll want to isolate data centers You'll want to have the framework that I would adopt for providing high confidence that we're not deploying AIs with sleeper agent, like latent sleeper agent capabilities, is that there's been discussion of RAND security level frameworks for data centers. And SL5 is this level that was defined largely by what its goal was and not by how to implement it. And its goal was to prevent the unauthorized access or modification of an AI system by a actor who is resourced at the level of a nation state. In short, how do we prevent, what do you need to do to keep China from stealing your model?
Or even
Iran
NVIDIA,
or North
because
Korea. Yeah.
even NVIDIA, because they're practically
Yeah.
bigger than Germany. So
Yeah. I think, or how do you prevent one frontier lab from stealing another frontier lab's model? I think that this description is fairly brief in the report that proposes it. The Institute for Security and Technology has a working group that is talking about what it would mean to actually be able to implement SL5. And the working group is defining this as an actual specification. And they hope to have this to be like fairly actionable checklist by the working group's conclusion later this year. There's a lot of, it's a fairly secretive group until the publication goes out. I think I have not found anyone talking about this very blatantly, but I was generally told, yeah, Evan, you can mention that it exists, that it's housed here, and that you're a member. Everything else is NDA'd. So I don't think that this is necessarily a scoop, but I think people who are watching this may want to stay tuned to what it would look like to have a secure data center and see the standard, like the product of this working group when it comes out. And I think that the two halves of having this assurance are going to be having a standard and iterating on that standard. And so I think the role of red teaming and blue teaming are finding gaps in the standard or traditional implementation and then updating the standard to implement the improvements that are needed in order to provide the security you need. I think that this goes back a little bit to the formal verification gaps, but there's a meaningful gap between all of the ways in which people think their AI system could be attacked and maybe the reality of how their AI system may be attacked, where in this case, the model is not of the universe, but it is a model of your adversaries who are always changing and going to come up with new things. And so maybe this is a really good instance of where the gap, if you are high confident that you have built the thing that you understand to be relevant, that is still not sufficient to have perfect confidence because your adversary is evolving and your adversary is the foundation of your model of reality.
and I have a hopefully intriguing question, because it at times seems to me that the concept of open source solutions is almost on the other end of secure environments. And it seems like with China's recent announcement of trying to go open source as much as possible, that they're maybe going a completely different route. I was wondering if you could maybe add your insights into these kind of different paradigms of working with AI.
Yeah, I will note, coming from the open source world at Protocol Labs, I am very in favor of people having things that are net defense dominant, like cryptography, even if there are military applications. And I am net in favor of people with having technology that increases their agency generally. I think that AI is unique. And I think that the fruits of AI would be great to share, like should be shared with all of humanity. I think that open weights now are great and I love them. And maybe when we hit the next biorisk trigger, I will suddenly be. I mean, no, actually, this is like there's a bit of a tragedy of the commons here, where like obviously I trust myself to use a model that has capabilities to end the world. I'm not trying to end the world, but if everyone has this, then we start looking at technology on a spectrum from how much does this like empower and protect you to threaten everyone by empowering each individual too much. And I have friends who are like, AI is like cryptography and guns. Like everyone should have a right to them. And on the other end of the spectrum, it's like bioweapons or like an antimatter bomb that could like annihilate all life on Earth. It's realistically the one thing that we could feasibly build that I think superintelligence might be the thing that we are more likely to build than anything else that could wipe out all life on Earth. I think fairly intuitive if you extrapolate what is the fact that we don't know how to control or set what a superintelligence would want. It's a superintelligence, it will presumably achieve that goal. So I tend to be very worried about open models on longer timescales. I think that if you said there were a dangerous open model that were released, I know what company I would expect it to come from, and it's not China, or it's not coming from China. I think that as soon as you have a model that is meaningfully dangerous, China changes its policy. I think that the Chinese government is far more technocratic than the American government. And I think that it's also far more able to pivot quickly. And I think that this is rarely something that you want in a government where I would say governance structures are kind of your only mechanism other than like individual longevity of maintaining some coherence of values across time. I think that American institutions really start failing if they don't have the kind of inertia that comes from kind of being lumbering and being intentional. Maybe not lumbering, but at least like slow. I prefer like reasonably sized and slow than very big and nimble because that ends up in kind of a bull in a tea shop form of governance. But I think that I probably want more regulation on open weight models. Yeah, I can confidently say that I want more regulation on AI models than I want on pharmaceuticals, for instance. I think that the risk is just so much higher and the number of people it affects is so much higher, even acknowledging all of the risks that the opioid crisis has created or brought.
To me, one thing is interesting is that there are many different actors. There are like frontier labs and there are academic and government. How do you think they can cooperate with each other as best as they can? And also, like, what are the main bottlenecks do you see? Like you mentioned, you're concerned about some of the frontier labs that releasing open weight model or releasing dangerous AI. How do you think even competition cause misalignment and kind of incentive structure that is not right? And how can we design coordination effort better?
I think coordination on the across some of these is really important. I think one of the biggest gaps, and I'm actually someone I should set up an email address and share it with you. And when you post this, people can reach out. I'm trying to set up a very apolitical, truth-seeking forum where technologists from the Bay Area and lobbyists or policymakers or researchers from DC can talk more about what is feasible actually on the technical side, but also on the regulatory side. I think that this is an effort where like it's a pretty low bar to be team humanity. And it's like very easy to define that in a way that's broadly interesting. And I think most people that I've talked to think that just having a better understanding, more situational awareness, and like more clarity around, oh yeah, this is how much that thing would cost. If you wanted to require it, that company has a clear financial incentive to give you a number that is meaningfully higher or lower. But this is my best guess and have a fairly high trust ecosystem there. So I think that effort and things like it will be important for kind of widening some of those bottlenecks.
I had one more question, and kind of related to something earlier that you mentioned a little bit, but I don't know if you ever saw Jurassic Park, but there's a scientist in it, Ian Malcolm, who warned that scientists were so preoccupied with whether they could, in this case, create dinosaurs, they didn't stop to think if they should. And I kind of wonder what your take is on that, especially in the context of our conversation and AI in general.
Sorry for turning away, but my copy of Jurassic Park sits there. It is
Thanks.
not currently here because I realized I loaned it to someone. But yeah, I do love that quote. I think there's an element of that. I don't think it holds true of leadership at the Frontier Labs as much. I think there is awareness of the risks in a way that I don't think there is in the kind of development that I interpret Ian Malcolm to be discussing in that. And I think that there is a lot of really interesting symbolism and metaphor in that movie. One of my favorites is like in the very beginning, Grant gets two female seatbelt buckles in the helicopter and ties them together. And this is life finding a way. This is exactly what leads Jurassic Park was like mating two females in a weird way that to achieve a particular end. The I think that there's the lesson that I would draw from Jurassic Park is really that like closer to the chaos theory in the book where you can't predict exactly what it is that you cannot predict the impact of the thing you are building. And every time you build a new thing, there will be implications and ramifications, most of which you have not considered. And I think that there is some element of that. Part of what we're trying to do at Atlas Computing right now is just list all of the things that are systemic catastrophic risks that it seems like no one is dedicated to. Like maybe there are researchers who think about this, but there's no one where if you gave them 100x budget and said, we really care about this problem, go fix it, or go build a thing to fix it, that there is a team that is building things that can scale to that. And so far, I think I have about 50 items on this list where it's like, yeah, I think that would meaningfully degrade most humans' lived experience as a result of AI becoming better indirectly through this path. And there isn't an org that's focused on this or building a thing. And sometimes it's not even clear what the solution looks like. But figuring that out, figuring out how to resource those more, and I think being able to take seriously the fact that there are possible risks that we're extrapolating and thinking about them in a way that humans have historically really never done, other than maybe with bioweapons and nuclear winter scenarios, feels like a high bar. But I think we can do it.
Mhm.
And I guess the last question I wanted to ask, what do you think the most urgent bottlenecks in AI security today that deserve immediate attention? And also if you can point audiences to any reference that you think is relevant to.
I think this might be some amount of recency bias, but it might be merging the traditional defense contractor infrastructure and security assurance infrastructure with with the Bay Area understanding of what risks may come from AI, what it means to truly have a system that is super intelligent or even human level intelligent running in a data center. I think it seems like a thing where the more you are just around people, and maybe this is some of the cultish aspects of effective altruism, it seems like between that or DC, if you're in a group where people just ridicule the notion that a machine could want a thing and nobody takes it seriously, then one person is not going to spontaneously, by reading blog posts, start taking it seriously for most people, most values of that individual. I do think that having more mixing and conversation does unlock a whole lot of possibilities. I tend to believe a little bit less in great man theories of history than many people I talk to. And as a result, I think that trying to put something into the zeitgeist or into the national conversation or the public eye, things like this become very interesting. And I'm kind of just hoping we could do it before we see something that would change minds about this. The typical framing I've given for how big a catastrophe would likely have to be to make an impact is something of the scale of COVID in the time scale of 9/11, which I think is not impossible, but starts to feed the notion of like what viscerally we should be thinking about or aware of or trying to prevent.
Yeah. Thank you, Evan, for all the thoughtful conversation here, and we link a lot of resources after in the podcast for audience to know. And with that, thank you so much. Is there any final closing thought that you would like to share with the audience?
One thing that the AI going to terminate humanity question made me think that there's like a fun anecdote in a lot of fiction. When AI systems go awry, they're not deciding to kill humans. They were given a goal that was unsatisfiable unless the humans were dead. Like in Terminator, it was end war. That is underspecified. It determined war is a natural aspect of humanity and decided to kill the humans in order to achieve the goal it was given. And HAL 9000 was given the conflicting goals. Do not tell the crew the true nature of the mission, and do not lie to the crew. If they're starting to ask, the only way you can maintain both of those is by stopping them from asking. I was hoping to end on something that's more of like a positive note, but I'm like a I'm kind of gloomy. I do believe that people can solve these problems. I really like the approach of identifying the bottlenecks and clearing the bottlenecks, and I think that there's I think it's hard to find a single thing that I want to point to, because I think that this is a problem that relates to nearly every job. And if you are talking about automating your organization, then finding ways to formalize some of the policies so you can have a hybrid human synthetic labor org where the AI systems collaborate more transparently is a thing one could do. If you're a researcher thinking about these problems, looking into what some of the risks are. If you're an entrepreneur, look into some of these neglected organizations. If you're a venture capitalist, you probably ascribe some fraction to AI destroying a lot of value and recovering from a catastrophe. You should be proportionally invested in companies that would help recover from that catastrophe. Maybe even the companies that prevent that are preventing it by becoming very profitable because we're seeing warning signs that lead to adoption. I think that there are many for-profit things that can be done here. I think that a lot of people who are doing philanthropy should probably step up their timelines, because the kinds of things that happen before we have AI systems that can solve very, very, very hard problems are going to be more important than the small amount that you could spend to get AI to solve those problems, things like that. So I think there are a lot of things that everyone can do. I can't point to one big bottleneck. There's the bottleneck. The bottleneck is that I think not enough people are actually just aware of the risks, and they're not thinking about the kinds of potential. They're dismissing the tech CEOs talking up AI risks as marketing or something like that, and missing out that there are a ton of nonprofit founders who are spending all of their time thinking about this and giving up their salary to do it. And I'll share some references of various people talking about the kinds of risks, and I'll try and get them across. I'll try and provide some samples across various aspects of accessibility or political inclination or things like that to try and appeal to a broad audience.
Yeah. Thank you, Evan. That was a great conversation.
Yeah,
Splendid.
thanks for having me.
Thank you.